Hey, everybody. So we're looking at our practice test for our final today. Really, you can just think of it as the review for the final. When you guys go to do these problems, just make sure you're showing your work on a separate sheet of paper. There's 20 problems. Almost all of them require some sort of work. So just, show what you need to. All right. So I'm going to just, be skimming through this and just giving you some hints and doing, a few of them with you. So stick with me if you want to pause the video at any time and try some out and then go back and forth. Like that's probably the best thing to do. Okay, so problem number one starts by giving us congruent triangles. Okay, so first thing to kind of like reset your brain, we're going back to congruency. All right, we've been working a lot with similarity. We eventually get into that on this test, but we start with congruence. Okay, if you guys remember the two key things about congruent triangles, it's really simple. All of the corresponding angles are congruent and all of the corresponding sides are congruent. It's just a bunch of equal parts. Okay, on this problem, they want us to find x, y, and z. All right, the first thing I'm noticing is all x, y, and z are angles. All right, so I know that corresponding angles are going to be congruent. Here's the first thing I'm going to do. It's kind of hard to tell what parts correspond. I'm going to use this congruency statement to number off my vertices. So PHS, let's start with that. P1, H2, S3. Okay, on this one, triangle CNF. So C1, N2 and F3. All right, and let's start with X. Okay, here's what I notice. X is part of this angle right here. All right, that angle is, has a 2 next to it. It's going to correspond to this angle, okay, the 115. Right, and there it is. We can make our equation. We know that they're equal, right? So 6x minus 29 equals 115. Right, that's the big thing, right? From here, I'm hoping the two-step equation's really quick. You can add 29 to both sides. So 115 plus 29 gives me 144. So I got 6x equals 144. And then from here, you can divide by 6. And it looks like we're going to get x equals 24. Okay, so yeah, go ahead and put that in here. On the practice test today, you can check all of your answers and see if it's right. I'm assuming that one is. All right, from here, I'm going to do y with you, and then I'm going to leave z. Okay, here's why I want to take a look at y. Okay, y is part of this angle right here, right? All right, its corresponding angle, they both have 3's next to them, is going to be this one. Okay, and they're not giving you that corresponding angle. All right, so that is the first thing we need to find to be able to make our equation for y. Okay, how do we find this angle? Well, we can subtract the other two from 180. All right, and we now know what x is, right? It's a 24. Okay, you don't have to draw this, but we can plug x back in right there, and we can actually figure out the measure of this angle. All right, so let's do it. Okay, I'm just doing this in my calculator off to the side. 6 times x minus 29. All right, and x we just figured out is 24. All right, so I'm just going to type that in. 6 times 24 minus 29, getting 115. Okay, here's something I just realized. That was kind of unnecessary because I knew that this angle was 115 degrees because its corresponding angle is 115 degrees. Okay, so yeah, that was maybe unnecessary, but either way, we now have the two angles. So we can take 180, subtract those two angles. So 115 minus 36, and we can get the missing one. So let's see, 180 minus 115 minus 36, we got 29. Okay, so there it is. That's the measure of angle S. All right, 29, I'm gonna put it right there. Okay, cool. So now we can make our equation for y. We know that 3y minus 1, this angle, is equal to 29. Okay, I'm just going to do the math in my head on this one. Add 1 to both sides. We get 3y equals 30. Divide both sides by 3. Y equals 10. You can put that right here. Okay, so I'm going to leave you guys to go ahead and find z. All right. Z, they give you its corresponding angle. So there's no 180 thing required. You can just set up your equation. Okay, so take a pause on the video, try out Z, and then we'll move on. Okay, so moving along. Okay, the next few problems on this test gets into, name the theorem that proves the triangles are congruent and write the triangle congruency statement, if any. All right, here is a big reminder. Congruent triangles. Here's our 5 triangle congruence theorems. This is what it's asking. Is one of these being used? Okay, so, to get us going on this first one, if you guys remember, a lot of these have missing info. Okay, we need 3 pieces of information to have one of these triangle congruence theorems. And if there's not 3 pieces, we need to find it if possible. Okay, hopefully you guys are noticing on this one, shared side length. All right, we know a shared side length is congruent to itself. So I can go ahead and add my bars there. All right, this is, I think, the most straightforward side, side, side on both of these triangles. Okay, so go into these drop downs. The triangles are congruent by side, side, side. Okay, write the triangle congruence statement. Okay, here's something to point out. If they are not congruent, write NC. Okay, ours are, but if they weren't, we would put NC, capital N, capital C in this spot. Okay, so anyway, let's see what our pattern is. Okay, PQR. So PQR, that is what this triangle is following. So when I go to make mine, I'm going to follow the same pattern. I'm going to do PQS. Okay, so PQS. Actually, maybe I'll type that up. Okay, make sure they're capital. So I just want to point out PQS. See, I'm doing it lowercase. I bet you it's going to say I'm wrong. Okay, the first part's right, second part's wrong because I didn't capitalize it. Okay, so make sure to capitalize this on the review as well as the test. And it's still saying I'm wrong. All right. It's because I was thinking it was PQR. That is totally my bad. It's PRQ. Sorry, everybody. Okay, so if I were to go back and actually do this correctly, PRQ, that's the pattern. All right, good thing to realize. Okay, so my pattern on this one is going to be PSQ. Okay, so real quick, I just want to make sure. I want to see if the lowercase is actually wrong. PSQ. Oh, it says it's right. Okay, but please, just use capitals when we would normally use them. Okay, but looks like it's giving you both. Okay, let's keep moving along. Okay, and basically, these kind of get into doing the same thing. I do want to take a look at this very next one. Okay, because something happens on this one I think is worth pointing out. All right, so here's what I notice. Only 2 pieces of information on these. I need to find a third thing. Hopefully you guys are seeing the vertical angles. I know this angle is congruent to this. Okay, so there's our info. Are we using one of our 5 triangle congruence theorems? Well, I'll have 2 sides and an angle, right? My first thought is this using side angle side? Okay, the answer is no. Okay, remember side angle side is when that angle is between the 2 sides, excuse me. Okay, on this one, the angle is not between the 2 sides, all right? Okay, so really what this is using is side-side angle or angle side-side. Remember, neither one of these are one of our triangle congruence theorems. Okay, if that shows up, they're not congruent. Okay, so are the triangles congruent? They are not. Okay, down here, what we would pick for this is not congruent. And then what we would write for our similarity statement is NC, okay, for not congruent. Okay, capital N, capital C. Okay, so let's just double check this one. Okay, so yeah, look out for those. All right, so I'm going to let you try the rest of those triangle congruence theorem ones on your own. If you want to pause, try them out, ask some questions, and then we'll move along. All right, so let's see, moving past these. Okay, you might have already gotten to this one, but this is still a triangle congruence theorem problem. It's asking what additional information would be needed in order to prove the triangle's congruent by side angle side. All right, so here's what there's 2 things, okay? And really you writing this out as a sentence or a couple sentences is what I'm looking for, okay? But for it to be side angle side, we know that the shared side length would be congruent to itself, okay? And then you'd need to tell me what angles need to be congruent to have side angle side, okay? Remember, side angle side, this would have to be one of our angles, and on the other triangle, it would have to be between the 2 sides. these would need to be my two congruent angles. Okay, this information that I just put on the triangles is what you need to write as your sentence. Okay, and everybody's going to have a slightly different answer, but that's what I'm looking for. All right, one thing to point out, when you name these triangles, don't just call them angle A. Okay, specifically tell me the name of the triangle, or sorry, the angle, excuse me. Okay, this one right here, for example, would be angle DAC. All right, or CAD. Okay, but that is one of the names for the angle DAC. Okay, and really you could be writing this down here, angle DAC. Okay, or you can write the word angle if that helps. Okay, would need to be congruent to the other angle, and I'll let you figure out the name of that one. Okay, but yeah, write out a sentence. Okay, moving along, let's see. The next thing is a triangle congruence proof. All right, here's the nice thing about this. It's giving you drop downs for all of these. All right, which I think, and it'll be the same thing on the test. So this makes it, I think, quite a bit more straightforward. One thing I'm just reminding you of, when you guys go to start these, the first given piece of information, that's always our first statement, and the first reason is always given. Okay, remember, it's all about getting congruent parts. I think I'm going to go through this one with you. Okay, but once we get congruent parts, we know we can move on and to find our next info. Okay, we have congruent parts here. Here's the big thing. Drawing these triangles and putting that information on is really important. Okay, so go ahead on your paper. Go ahead and draw these triangles. All right, and let's first start by showing what they're telling us. Side JM is congruent to side NM. Okay, that's congruent parts. Cool, we can move on. Here's the next thing. L is the midpoint of JN. Okay, so that's our next statement, right? Okay, why do we know it? Because it's also been given to us. All right, here's the thing. That didn't get us congruent parts just yet. We need to look deeper and find what that's telling us. All right, so here's what they're telling us. L, this point, is the midpoint of JN. Here's JN. If this is the midpoint, it's cutting JN into two congruent halves. Okay, so here's what you can add to your picture. We know that this is congruent to this. Okay, and if you guys take a look, that's our very next statement. JL is congruent to LN. Okay, why do we know that? Remember, anytime you're told you have a midpoint, your following reason will always be definition of midpoint. Okay, all right, so that's all the given information. I'm looking at it. We only have two things on our triangles. We need a third missing piece of info. Hopefully you guys are noticing that shared side length. Yeah, that thing is congruent to itself. Okay, and that's our next statement. LM is congruent to LM. Okay, whenever something's congruent to itself or there's a shared part on these triangles, remember that's the reflexive property. Okay, last thing, which triangle congruence theorem is being used? This is where drawing on your triangles is so important. Looks like we have a side, side, side on both of them. There it is. And let's see if we're right. It's not saying that's given. Okay, that's wrong. Okay, that is given information. So when this says you're wrong on the practice test, you're not. Okay, so let's keep moving along. All right, so from here, it shifts from congruent triangles to similar triangles. All right, and the very first thing, they're saying these triangles are similar, solve for the scale factor from figure A to figure B. Okay, so what's the scale factor of these triangles? Basically, what's happening to A for it to turn into B? All right, if you guys remember, to find the scale factors, we can just set up a ratio of these corresponding sides. All right, and we can do any ratio here. Okay, the one I'm going to do is this short side length and this short side length. Okay, sorry, it's getting loud in here. Okay, so anyway, I'm going to do, normally we do left over right, and here's a point I want to make. Left over right, 27 over 9. Okay, these problems are going to want your answers as fractions. Okay, so we need to reduce this. Okay, 9 goes into both of these, right? 9 goes into 27 3 times, and itself 1 time. Okay, here's the thing to realize. 3 is not what this big triangle is being multiplied by to get the small triangle. Okay, it's actually the other way around. The small triangle is being multiplied by 3 to get the big one. Okay, so what we can do is we can just take that ratio and flip it, and it'll give us the scale factor from A to B. Okay, so actually 1/3. Okay, that's what this is being multiplied by to get this. Okay, so that's going to be your answer in here, a 1/3. Okay, so think rationally about those, and you can know when you need to flip the fraction one way or the other. Alrighty, moving on from here, this gets into using similar triangles to find missing side lengths. I'm hoping this is nice and fresh in your brain. These are your proportion problems, right? Okay, set one ratio equal to another, cross multiply. Let's see, I don't know if I'm going to do this one. Actually, maybe I'll set you up with this one and then we'll move on. All right. Here's your triangle similarity statement. Okay, if you're unsure on which parts correspond, number off the vertices using that. Okay, so let's do it real quick. CDE, C1, D2, E3. Okay, same thing with this one. FGE, F1, G2, E3. Okay, so now we can set up our ratio. This side length between 1 and 3 corresponds to this one between 1 and 3. Okay, I'm going to do left over right when I make my ratio, 27/x. Okay, setting that equal to the ratio of another pair of corresponding sides. This one between 2 and 3 corresponds to this one. Okay, I'm still doing left over right when I make my ratio, 25/40. Okay, and just to do the whole thing with you, let's go and cross multiply. 25 times x equals 27 times 40. So let's see, we're getting a 25x equals 27 times 40. Okay, 1080. Okay, and then last thing, get rid of the 25 by dividing. Okay, and we're actually getting a decimal in this one, so let's see what happens when we write it in. We're getting a 43.2. All right, so yeah, let's see if that's actually our answer. All right, so yeah, it's possible to get decimals on these. If I did, I would double check, but yeah, it happens. Okay, so yeah, if you want to go ahead and try out these problems, the next one is asking you to just find x. All right, so you're just finding this side length here. All right, go ahead and make a proportion on that. The following problem uses the same triangles, but it wants you to find y. All right, so go ahead and pause the video. Maybe try those two out. Okay, from here, the problem's more of the same, similar triangles. All right, the big thing on this is just be careful when you cross multiply. Okay, you're going to be, multiplying one number times x minus 3, and that's going to have to be distributed. Okay, but I think I'm going to leave this to you because I've done a lot of these with you. Okay, from here, it kind of switches gears and it's asking, determine if the triangles are similar. Okay, and then, why are they similar? Okay, on these problems. Okay, these are asking you to figure out which triangle similarity theorem is being used. Angle, angle, side, 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 angle, side. Okay, big thing to remember. When you're dealing with these ones with sides, you have to set up the ratios of corresponding sides and see if they're equal. Okay, so I'm trying to think of which one I want to do with you guys. I think I'll do this one. Okay, so yeah, first thing I'm noticing, they're giving me just 2 pairs of corresponding sides. Okay, here's what I can add to this problem. Vertical angles, we know are congruent. Okay, so my hope is you're thinking, all right, potentially this is using side, angle, side. Okay, that's my first thought after I find my vertical angles. To be certain, we need to see if the ratios are actually equal. All right. It's kind of hard to tell, but these triangles are kind of flip-flopped. Okay. Here's one thing to notice. This is the smaller of these two sides. It's going to correspond to the smaller of the two sides here. Okay. So there's one of my ratios. 63 over, is that a 39? I cut it off. Yeah, 39. Okay. And I'm wondering, is that equal to the ratio of the other pair of corresponding sides? Okay. Notice what I did when I made this ratio. Top triangle over bottom triangle. I'm still going to do top triangle over bottom triangle. Okay, on these, we don't need fractions, just divide them, see if they give you the same number. So 63 divided by 39 gives me a 1.615. Okay, it goes on, but I should get the exact same number on this one if they're similar. 84 divided by 52, yeah, 1.615, and it goes on. All right, so yes, looks like that works out, and these are similar. Okay, so the triangles are similar because of side angle side. Okay, and now we can complete our triangle similarity theorem. All right, let's look at the pattern. QRS. So starting at Q, going around R to S. Okay, when I go to make this other one, it's going to have to, basically mirror it, and it's going to be URT. Okay. So it's saying I'm wrong on the top and on the bottom. Interesting. I'm going to have to double check this one. Maybe you might have caught my mistake if I made one. I feel like I didn't. I think this one might be entered wrong in the practice test. Real quick, I'm going to divide these again and just make sure they're exactly the same. Okay, so this is 5, 6.1, 5, 3, 8, 4, 6. Okay, I'm just making sure if these decimals are like not exactly the same. 6, 5, 3, 8. Yeah, no, these are the same numbers. Okay, this problem is correct. Ignore what it's saying in Otis. I'm sorry about that. Okay, so yeah, I'm gonna have you guys go ahead and just try some of these triangle similarity theorem problems out. Okay, on this one, make sure to set up all of those ratios. Okay, just remember the way this is going to work. The short side of this triangle is going to correspond to the short side of this triangle. The next biggest side of this is going to correspond to the next biggest side. And the longest side is going to correspond to the longest side. Okay, so that's going to be your ratios. All right, let's see. All right, from here, this gets into what we learned most recently, and this is the triangle proportionality theorem. All right, where basically when we have a line parallel to the side, okay, we know that the side lengths are divided proportionally. All right, so on this problem, when we go to make our ratio, it'll be this over this equals, let me change colors, equals this over this. Okay, I'm going to let you do this one on your own. I want to do one that's a little trickier. So if you want to skip with me over. Okay, take a look at this one. Same idea, triangle proportionality theorem. Okay, when I go to make my ratio, the first thing I'm thinking is, all right, one of my ratios is going to be the two parts of this side. So an x over 18. Okay, I'm just going to write that out as my first ratio. Okay, and that's going to be equal to the two parts of this triangle, this over this. Here's the big thing to realize. This part right here, we aren't given, okay, but we can easily find it. If the entire thing is 28 and this part's, 21, this must be 7, right? 7 plus 21 gives us 28. Okay, so there's our other ratio, 7 over 21. Okay, and from here, we can cross multiply and get our answer. Okay, so 21 times x is 21x. Equals 7 times 18, 126. And then divide both sides by 21. Looks like we're getting x equals 6. Okay, last one, take a look at number 20. Okay, this one ends with a triangle similarity proof. All right, these are a lot like our triangle congruency proofs. All right, and when we go to start these, just like before, the very first thing we'll always look for is that first given piece of information. Okay, PS is parallel to FC. Okay, they're already showing that on our triangles. If they hadn't, we would put the little arrows ourselves. Okay, but down on our proof, there's our first statement. Okay, what's the reason? It's been given to us. Okay, here's the thing. That's all that's been given. Okay, and ultimately our goal is to say these are similar using one of our 3 triangle similarity theorems. Okay, just flipping back to them real quick. Okay, which one of these is being used is our goal. All right, so let's see what else we can find on these triangles. All right, so here's my first thing I notice: vertical angles. All right, this angle is congruent to this angle. And really, if you take a look at the next statement, really we would want to follow this, and that is what they're saying. Angle APS is congruent to AFC. Okay, so actually what they're pointing out first are these. APS is congruent to AFC. Okay, they're pointing out that these angles are congruent first. Okay, that wouldn't be the first thing I would do, but we want to follow the statements that they're writing out. All right, so here's the thing to realize. This is being created from 2 parallel lines being cut by a transversal. Okay, what do we get here? Alternate interior angles. All right, so that is actually going to be what we write for our reason on this one. Okay, write the whole thing out. Alternate interior angles. Okay, so we got 1 pair of corresponding angles congruent. That's good. Okay, what's the other thing? This is where pointing out the vertical angles is the next thing I would do. Okay, angle PAS. Yeah, this angle is PAS is congruent to angle CAF. All right, so yeah, the vertical angles, they're congruent, and our reason is because they're vertical angles. Okay, write the whole thing out. Spell it correctly. Okay, so here's the thing we've got to realize. We now have similar triangles. We have 2 pairs of corresponding angles congruent. That's using angle-angle similarity. All right, so yeah, triangles are similar. And the last thing, we can just say angle-angle. Okay, it's likely when you click check answer on this, it's going to say maybe 1 or more of these are wrong because maybe you spelt it a little differently than Otis was wanting. But we'll check these problems on the actual test. Okay, so yeah, there is the review for the final, guys. Go ahead and shout out the other problems that I didn't get to and ask me some questions.